Today we're going to learn about angles, how to name them, and finding angle measure using angle addition postulate. First of all, we need to know what an angle is. And an angle consists of two rays that share an endpoint. So you can see in my diagram, I have two rays that are starting from the same endpoint. And we call the sides of an angle the rays. So the rays are comprising the sides, and the place where they meet at this endpoint, the pointy part of our angle, is called the vertex. So we're going to have to keep that in mind as we do example 1. I'm asked to name the angle, its sides, and vertex. Angles can have alternate names just like line segments and lines can. So our first name for our angle, we're just going to name it by the 3 endpoints, and the deal is you've got to make sure that they stay in a particular order. Our vertex will always be the middle letter. So when I name this angle, I can call it angle PQR, or I could reverse that and I could call it angle RQP. But the important part is making sure that your vertex letter is in the middle. In some cases, I can also use just the vertex for a name. So this could be angle Q. Now let me show you an instance where that will not work. If I'm giving you an angle that looks like this, but then it's got an additional ray coming from it, and we can call this ray QW. In this case, if I said angle Q, I'm looking at 3 separate angles because I have this large angle we just looked at, but then there are 2 smaller angles inside. So calling a particular angle in this diagram angle Q is not being very specific. So instead, you've got to name it using one of these methods here, using the 3 letters. So if I was talking about this small angle here, I'd have to call that angle PQW rather than calling it angle Q. Okay, so let me back up here and let's talk about naming its sides. Now, my diagram definition up here says that the rays comprise the sides of an angle. So here's my endpoint at the vertex, and the ray that's pointing towards the left would be called ray QP. So naming rays, you start with the endpoint and then you move outward. So for this ray, I'm going to start at Q and I move towards R. So my 2 sides are rays QP and rays QR. The vertex is the endpoint that the rays share. So the endpoint in this diagram would be Q. So Q is the vertex. So I have my names, my side names, and my vertex named. Let's talk about classifying triangles and classifying angles and congruent angles. Congruent angles are just like congruent segments where if their measures are equal, we call them congruent, and we can use the congruency symbol that looks like an equal sign with a squiggle on top. So if I wanted to say one angle is congruent to another, I would use this symbol here. Now as far as classifying, they're a little bit different than naming because you're telling me what type of angle they are. Acute angles measure less than 90, and they typically look something like this, where they're kind of scrunched together. Okay, obtuse angles measure between 90 degrees and 180 degrees, and that can look something like this, where it's open up real wide. A right angles measure is exactly 90 degrees, and so if you think about the corner of the page in a book or in your notebook, that would be a right angle, and right angles are usually indicated by a little box that lands on top. So this box tells me that this is a right angle. And then straight angles measure exactly 180 degrees. 180 degrees just looks like a straight line. So here are some examples of your classifications. In example 2, I'm going to give you the measurement and we're going to classify what each one is. So if we look at our A example here, it says that measure A is equal to 130 degrees. According to my definitions, 130 fits between 90 and 180, so that means that A is obtuse. B says that measure of angle B is equal to 90 degrees. Now the one that measures exactly 90 is this right angle. So B is a right angle. And in C, measure of angle C is equal to 45. So since that is less than 90, then that means that C is acute. Okay, moving right along. Let's talk about the angle addition postulate. Angle addition postulate is very similar to the segment addition postulate in that it states that when you have two smaller angles add together, they are equal to the larger angle. So in here, angle ABD would be this angle right here. And angle CBD would be this angle here. So I have two smaller angles, and together they're making the large angle ABC. So we're going to be using this property to find example 3's answers. Alright, so for example 3 it says find the measure of ABC. So basically what this is telling me is that the small measures add up to give me the large measures. So writing it in formula, as a formula, I can use my small angle ABD, add that to angle CBD, and that should equal the large angle ABC, which is the one that we want to find. So plugging in ABD is 30 degrees, indicated there by that 30. I'm going to add 40 degrees to it since that's the measure of CBD. And 30 plus 40 is 70. So the measure of ABC is 70 degrees. Now in B it's a little bit different because this time I'm given two angle measures, and here we can see that I have an arc here, and when you see that, this arc is talking about the entire large angle. So angle DBA is the 135, which is noted by this arc, and my DBC is 60 degrees. So when we're finding the measure of ABC, we're looking from this ray to this ray. We want to know what is this angle measure. And I can use the same formula basically to figure this out. So I have DBC. So I'm going to take the measure of DBC. If I add that to measure of angle ABC, then that should give me the entire angle DBA. Oops. Okay. So let's fill in our blanks here. I've got DBC. DBC is 60 degrees. ABC, that's what we don't know. That's my question mark. So let me fill this in as an X since we don't know what it is. And DBA, that entire measurement is this 135 degrees. That's denoted by our arc. So now to get X by itself, we're going to have to subtract. So I'll subtract 60 degrees on both sides. And 135 minus 60 is 75. So X is 75 degrees and X is ABC, and so we found our missing angle measure.